What's up, everyone? Welcome back. In this question, we have what seems to be a sheet metal part, but we're not going to be doing it as sheet metal. We're going to be doing it with normal extrusions. So getting straight into it, we can see that we have a base with some cutouts, one at a slightly irregular angle of 35 and another one at 45 degrees. So 45 because it's 18 and 18. We have a distance between the corner and this edge. We have a little flap bent up on the one side, and the dimensions of that are given here. And okay, let's jump straight into it. So getting into it, we can start with a rectangle from the top plane. We have dimensions of 64 on the vertical and 108 on the horizontal. We have a cutout here of some angle, which we will input in a bit, and we can do this angle here as well. So dimensioning them, we have 35 degrees here and 45 degrees on this side with one dimension. So we can either do it as an angle and a dimension or two dimensions. Guess which one I chose. Okay, then we need to dimension from this point to there, and we have a dimension of 54. And this internal segment here is our shape. So the questions generally specify, in this mock exam, they generally specify how many features you can do it in, or the least amount of features you can do it in. I don't really follow that. I prefer to go along with what makes more sense or what's easier to modify later on, because sometimes the more complexity you have in a sketch, the harder it is to update it when using global variables. So I'm going to add in the fillets now. We have two fillets on either corner, and each of those fillets is a dimension of 12 millimeter radius. So that's 12, and then we can add in our circles, and our circles are going to be concentric to our fillets. So we have two circles, we can make these two equal and dimension one of them. The dimension of this hole is going to be 10 millimeters. Okay, we can confirm sketch, we can cut that away. Through all is fine. Okay, cool. Now we need to work on our flap. So to work on our flap, we're going to create a plane that is perpendicular to that face and coincident to that one, so that we get a 90-degree view starting from that corner. So with the plane selected, we can go ahead and start our sketch. So we have a circle that lies somewhere here of some dimension, which we need to confirm in a bit. Select midpoint, coincident, and then we have a line off to the side that is tangent. The dimension of this line is going to be 14, and the dimension of this, because we're working from the center, is going to be 10 millimeters on the radius, so that's 20 millimeter diameter. We can go ahead and trim that away, and we know that we have an angle to the horizontal of 112. Okay, so that's all. We can offset bidirectionally, and we can cap the ends with lines, and we can use base geometry to change this from solid lines to construction geometry. And we're going to follow the same thickness that we have on the rest of the part, which is 4 mils, so that's 2 mils either side, and that looks good. Hit the tick. We can confirm our sketch, and now we can extrude. This time it's going to be up to vertex, and we can select that point. Cool. We don't need to see this plane anymore, so we can hide that. And that is our shape done. So now all we need to do is add in our material. We have a material of manganese bronze. So manganese bronze, here we are. That's our material applied. And that's our shape done. So let's check our mass. We get a mass of 239.55. Heading back to our PDF, the answer is given as 239.55. Well done. Hopefully you guys got the same answer that I did, and the same answer actually given in the question. Let me know how you guys got along in this question, and if you have any feedback, please let me know. If you enjoyed the video, give a like and subscribe. Hope you guys enjoyed this video, and I will see you in the next one.